Welcome to the CAEN spectroscopy video tutorials. In this video, we will learn to use the Energy tab of the device setting window. First step, connect hexagon to the detector and the Quantus software to the board as explained in the video tutorial Quantus Spectrum Acquisition. Second step, open the MCA Signal Inspector window as explained in the video tutorial MCA Signal Inspector. Third step, set the parameters on the Input tab as explained in the video tutorial MCA Input Settings. Fourth step, click on the Energy Filter tab of the Device Settings window. Set the trapezoidal signal on the analog probe 1 and the input signal on the analog probe 2. The digital signal processing applied by the MCA allows to convert an input exponential signal into a trapezoid signal. The baseline of the trapezoid is evaluating by a moving average algorithm and then subtracted to the trapezoid. A corrected trapezoid is obtained having an amplitude proportional to the input signal. The main parameters affecting the acquisition are the trapezoid rise time, the trapezoid flat top, the peaking position, the pure protection time, and the baseline restorer. A correct setting of these parameters allows to optimize the acquisition. The trapezoid rise time sets the bandwidth of the digital filter. In case of high-resolution measurements, it has to be set in such a way to minimize the current noise and the voltage noise. A short rise time reduces the effect of the low-frequency noise, while a long rise time reduces the influence of the high-frequency noise. Several acquisitions with different rise time values can be useful to find the best shaping time for your setup. The flat top region is used to evaluate the amplitude of the trapezoid. The flat top value is fully related to the rise time of the input signal. In case of ideal input signal with fast rise time, no ballistic deficit is seen on the flat top. However, in case of real signal, in particular in case of large germanium detectors, a slow rise time of the input signal causes a ballistic deficit on the trapezoid flat top. In these cases, it is useful to use longer flat top values. Moreover, the exact point used to sample the amplitude of the trapezoid can be chosen by setting the parameter peaking position. It has to be set avoiding a flat top sampling on the ballistic deficit region. The pile-up rejector protection time allows to set a time interval during which events after the main one are rejected. It is particularly useful in case of high rate acquisition with a highly variable trapezoid baseline. The baseline restorer allows to set the length of the moving average window evaluating the trapezoid baseline. In case of stable trapezoid baseline, set it at high, otherwise set it at medium or low. In case of periodical vibration, mainly due to electrically cooled detectors, a low-frequency rejector digital filter can be activated to minimize the effect of the vibration on the resolution. On the right part of the tab, it is possible to set the parameters of the single channel analyzer. As soon as a low threshold and a high threshold are set, for each signal falling in that region, a digital pulse is set to the hexagon GPIO and the counters are updated. In the bottom part of the tab, it is possible to set the spectrum number of channels from 256 up to 32K channels. Tutorial completed. Check the CAEN website for other video tutorials. Thanks for watching.